In this class, I will explain about the basics of hydrostatics and how we can compute the pressure force exerted in cases where a surface is immersed in a liquid. Now, just to understand the concept of hydrostatic force, I will take the example of a dam constructed to store water. So, this is the reservoir portion where water is stored. Let us take H as the depth of that water stored in the reservoir portion, and this is the dam. Now, if you consider the hydrostatic pressure exerted by water on the wall of the dam, so this is the wall of the dam. So this pressure distribution diagram will be a triangle like this. This I have explained in the earlier videos. So the pressure here, I will take it as intensity here, I will take it as 0, and at the bottom it will be equal to gamma W into H, because P is equal to gamma into H. Gamma W is the specific weight of water. Since H is the depth of water stored in the reservoir, gamma W into H gives the pressure intensity at the bottom of the dam. Now here, this is having a linear variation. So P is directly proportional to H here. So it's a linear variation. This I have proved. This is the hydrostatic law. So in this case, if you replace this proportionality sign by equality sign, it becomes gamma W into H. That is why it is a straight line. Variation of pressure intensity is a straight line across the depth. Now if I take the area of this triangle, so area of the triangle becomes here half into gamma W H into H, which is half into gamma W into H square. This expression gives the total pressure acting on unit width of dam surface. Suppose if you consider unit width of the dam, so unit width of the dam wall will be a rectangular wall of width 1 meter like this, and H is the depth of water. So this is the projected area. You can call it as projected area. So if you take the projected area, it becomes H into 1, because it's a rectangular surface. H into square will be projected area. So whatever pressure is acting over this area, over this H into 1, that is given by this expression. So this is nothing but, even though we call it as total pressure, it is nothing but force. It is an expression for force. So when the force acting is divided by the projected area, we are going to get the intensity of pressure. So this P, this force P, you can call it as P here. This P will be acting at some point here. That point is called as center of pressure. So Cp is called as center of pressure. P is the total pressure, which is expressed in kilonewton. So center of pressure is this point where that P is acting. And you have one more called H bar. H bar is the depth of center of pressure from the free surface. So H bar, that will be in meters. Now this pressure force P can be found out using this formula gamma W into A into X bar, where A is this projected area and X bar is the depth of CG. Suppose if you locate the CG of this rectangular surface, it will be somewhere here. So this will be your X bar. Suppose if it is rectangular area, so this becomes your X bar. So X bar is the depth of CG of the area from the free surface. So this is how we can calculate this value of P, either by using the pressure diagram or by using this formula. Now I will give another example wherein you have a gate. A gate is situated here. So water is resting on this side also and on this side also. This side is called as upstream side, this side is called as downstream side, because water flows in this direction from upstream to downstream. Now here what happens, if you use the same formula, so suppose if H1 is the depth of water on the upstream side and H2 is the depth of water on the downstream side, so the expression for P1 will be gamma W into A1. So A1 is this area. So suppose if we take this height, if you take this height, well, this height is multiplied by the width, corresponding width, you are going to get A1. That is, A1 is the area of the upstream side, A2 is the area of the downstream side, this side, they are different. And x1 bar is the depth of central pressure of this area from the free surface, and x2 bar is the depth of central pressure of this area, corresponding area of the downstream side from the free surface. So if you know all these values, you can find out P1 and P2, and the resultant force in this case, because water is exerting pressure in this direction in the upstream side on this gate, and it is exerting pressure in the opposite direction on the downstream side. Therefore, we have to calculate what is called as the resultant force. Resultant force is nothing but the difference between these two forces because they are acting in the opposite directions. So this is another example. So one example is dam example where water is exerting pressure on the walls of the dam, which is given by this formula. Another example is it is example of a gate where you have water on both the sides when the gate is closed. So what is the resultant force acting on the gate? So that type. So these are called as hydrostatic forces because water is there. Some other liquid may also be there. So if other liquid is also there, then also we have to use the same formula. Only thing is here instead of gamma W you have to use gamma. So gamma is specified as a particular liquid under consideration. Now there are two cases here. One is suppose if the surface which is immersed in that liquid is vertical and if it is inclined. So there are two cases here. So force on a vertical surface immersed in a liquid. So let me take the liquid as specific weight gamma. It may be water or any other liquid also. So this is the vertical surface which is immersed in that liquid. Now this whatever liquid is there here on this side or this side, it exerts pressure on the face of the vertical plate or the vertical surface. Now that force I am taking it as P. So P is the force here and Cp center of pressure is here, center of gravity is here. I have taken the example of a rectangular surface here, assuming that this plate is rectangular shape, it's of rectangular shape. So perpendicular to this board, it looks like this. So B is the width of that rectangle, D is the depth of the rectangular plate. So in that case, so this P force is given by gamma into A into x bar, where A is this total area. Of course, here in the case of a dam, I have taken per unit length, per unit width of the wall of the dam. Whereas here, if you have a plate, then you have restricted width for that. So B and D, they are the dimensions of the rectangular plate. So here, this A becomes here in this case B into D, B into D. So this is the formula which is used to find out the force on this plate, force of this liquid on this plate. This x bar you can always find out because you will be knowing this distance, and also since you know this dimension, so this will be d by 2 from here. So from A to CG it is d by 2. From here to here you will be knowing that value will be given. So x bar you can easily find out. So gamma A x bar is P value, and this depth of center of pressure h bar is given by x bar plus Ig divided by Ax bar. So you can see here this x bar is greater than x bar. That means center of pressure always lies below the center of gravity. So this distance, so whatever this distance is there, that you can prove that it is Ig divided by Ax bar. Therefore, your x bar will be x bar plus Ig divided by Ax bar, where Ig is the moment of inertia of the projected area. Projected area means that area of the surface, whatever is given, about the horizontal centroidal axis. This is the horizontal centroidal axis. So if you calculate the moment of inertia about this, suppose if it is a rectangular plate, it is BD cube by 12. You know that. If it is a triangular plate, it becomes BH cube by 36. If it is a circular plate, it becomes pi d power 4 by 64, where d is the diameter of the plate. If it is semicircular plate, it is pi d power 4 by 128. So in rectangular plate, it is B is the base of the rectangle and H is the altitude of the height of the rectangle. So these formulae you have learnt already. So using those formulae, if you substitute the values for I, V, A and X bar, you can get the value of H4. This is the for the case of a vertical surface. Suppose if the plate is inclined, so making an angle theta. So angle of inclination here is theta. If it is inclined with the free surface with an angle theta, then the expressions will be little bit different. So of course the expression for P remains the same. Gamma A x bar, where gamma is the specific weight of the liquid in which that plate is immersed, and h bar is once again the depth of the center of pressure from the free surface. In this case, it is given by x bar plus Ig sin square theta by Ax bar. This is the formula. So once again here Ig is the same what I have explained here. Only thing is this theta value you have to substitute sin square theta, and then you have to simplify. Suppose if theta is 90 degree, then it becomes a vertical plate. So sin square 90 becomes 1, then this expression reduces to this expression only. So here I have given the example of a circular plate here. Here I have rectangular plate, here circular plate. In this case of circular plate, diameter d is there. So you can see that in both the cases, h bar is greater than x bar, or you can say that center of pressure always lies below the center of gravity. So this concept of hydrostatics, that is the concept of total pressure and center of pressure, all those things, it is very helpful in computing the force exerted by water or any other liquid on a surface which may be vertical or inclined, immersed in that liquid. So these are some practical examples we can analyze using this concept.